All right, so today I'm going to go over a couple of examples from our review sheet for our test on Monday. Our test will be Monday, so please be sure that you have the review sheet done and that you are prepared for the test. So I'm going to start with number 1. To simplify the square root of 360, basically all I do is I do my factor trees. So 360 would be 36 and 10. Factors of 36 would be 4 and 9. Factors of 4 are 2 and 2. Factors of 9 are 3 and 3. And factors of 10 are 2 and 5. So remember, when I simplify, I'm looking for pairs. So I have a pair of 2's and a pair of 3's. And when I write this, the pairs always get represented on the outside. So since I have a pair of 2's, I'll put a 2 on the outside. I have a pair of 3's, so I'll put a 3 on the outside, and then the stuff that's left over gets put underneath, and I have to just multiply everything back together. So 2 times 3 gives me 6, and 2 times 5 gives me 10. So I have 6 square root 10 as my simplified answer. For 2, because there's a negative underneath the square root, I pull the negative out as the imaginary number I. So now I can do my factor trees of 3024. All right, so I'm going to divide 3024 by 4. And I get 756. Factors of 4 are 2 and 2. 756, I'm going to divide by 4, and I get 189. Factors of 4 are 2 and 2. I'm going to divide 189 by 9, and I get 21. Factors of 9 are 3 and 3, and factors of 21 are 3 and 7. So I have a pair of 2's, another pair of 2's, and a pair of 3's. So I put all of the pairs on the outside, so I have 2 times 2 times 3, and then I'm left with the 3 times 7 underneath the square root. So 2 times 2 is 4, times 3 is 12, and then 3 times 7 is 21, and because I pulled out that negative with an I can't forget the I here as well. Now we have these other types of problems where we have to simplify these. So like for number 6, if I take 960, I know I can do my factor trees of that. So I get 96 and 10. Factors of 96 would be 3 and 32. Factors of 32 would be 4 and 8. Factors of 4 are 2 and 2. Factors of 8 are 4 and 2. Factors of 4 are 2 and 2. And then factors of 10 are 2 and 5. So I have a pair of 2's, another pair of 2's, and another pair of 2's here. So if I put all of those pairs together, so I have a 2 times a 2 times a 2 on the outside, and then I will have to multiply the leftovers back together, so that would be 3 and a 5 underneath. So 2 times 2 is 4, times 2 is 8, and then 3 times 5 is 15. So I have this 5 plus or minus 8 root 15 all over 3. And then I double check. Are 5, 8, and 3 all divisible by the same number? No, they're not. So this would be my final answer. All right, so for 10 and 11, it says we just have to solve for x by simplifying any radicals. So to do that, we have 2 methods to be able to solve. We have completing the square to solve, and we have using the quadratic formula. Since it doesn't matter which one we use, you can use whichever one you would like or feel most comfortable using. I am going to do an example of one of each, so you have that to be able to study from. So for 10, I'm going to use the quadratic formula. So I know that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And since this equation is equal to 0, I know a is 1, b is 5, and c is 1. So now I can replace the letters with the numbers that each is. So negative b would become a negative 5 plus or minus the square root of b, which is 5 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. And now I just have to simplify. So I get out my calculator and I multiply, I figure out what's underneath the square root. So I take 5 squared minus 4 times 1 times 1, and that gives me 21 over 2 times 1 is 2. So then I look at my answer here and I see, okay, so I have 21. I know 21 is not a perfect square, so if I try and do factor trees of 21, I just get a 3 and a 7. Since there's no pairs, that means I can't simplify this anymore, so my answer would just be negative 5 plus or minus the square root of 21 all over 2. Now for 11, to solve using the completing the square, I know I have to have it equal to 0 first to be able to complete the square. So I'm going to add the 2x to both sides. So I get x squared plus 2x plus 1 equals 0. And then I'll draw my box. And I know x squared has to go in this top part. Half of this goes in these other two boxes, so half of 2 is a 1x and a 1x. And then remember, this plus 1 goes outside of the box. So then to figure out what goes in here, I take my numbers and I multiply them together. So 1 times 1 is 1. And whatever we put inside the box, we have to do the opposite outside. So that means I'm going to subtract 1 out here. So now these two boxes have an x in common. These two boxes have a 1 in common. These two boxes have an x in common. These two boxes have a 1 in common. So I get x plus 1 squared. And then plus 1 minus 1 would be 0. So I'm not even going to bother writing that. And I know this has to equal 0. So then to solve, to get rid of the square, I'm going to square root both sides. So I get x plus 1 equals plus or minus, and the square root of 0 is 0. So I'll subtract 1 from both sides and get x equals negative 1 plus or minus 0. But if I take negative 1 and add or subtract 0, I just get a negative 1. So my answer is negative 1. Now you can use the rest of the time to finish the review sheet. Our test is Monday.